All right, here in lesson 5.8, we're going to be solving trigonometric equations. As you see right here at the top, it says strategies for solving trig equations. Sometimes we'll use trig identities. We might have to use factoring, use properties of equality, and use inverse trig operations. So we don't use them necessarily in that order. Those are just some things that we're going to consider when we are solving equations. When we solve, we're usually going to be finding the primary solutions. And those are the solutions from 0 to 2 pi, which we would say that's within the first rotation or the first period. So oftentimes there's going to be two solutions. And we will look at that as we work through. So we're going to just jump right in. These examples are going to try to pick up on some of these ideas that are listed in the strategies. So we see some examples of each of those. So the first one, it says solve tangent of x minus root 3 equals 0. This one's going to be pretty straightforward. We want to solve for x. And so what we're going to do first, in this case, since it's just a single tangent x, there's no other trig ratios, we're going to go ahead and add root 3 to both sides. That gives us tangent x is equal to the square root of 3. And now what we're technically doing is we're using inverse trig operations. We're thinking inverse tangent of both sides. And we can write it. We don't have to write it. We usually kind of just, another way to do this is think through it. So really we're thinking, when does tangent equal the square root of 3? And that should be familiar to us. That is one of the special angles that we've looked at before. So we have a chart that we look at sometimes. Tangent equals the square root of 3 at pi over 3. And that's in the first quadrant. And remember, tangent is also positive in the third quadrant. And so what's a pi over 3 angle in the third quadrant? Well, that is 4 pi over 3. Not 5, 4 pi over 3. And so those are the primary solutions. You don't need to write this, just to make you aware. Remember, so tangent is going to be a rough sketch. Just, it looks like this, and it keeps going and going and going forever in both directions. And so technically, root 3 is about maybe right here. So tangent actually hits root 3 an infinite number of times, but we are only getting them between 0 and 2 pi. All right, next one says solve 2 cosine squared x plus 3 cosine x plus 1 equals 0. When you see something like this, it's still just one trig ratio, only cosine is involved. But this kind of looks like, or it is, a quadratic equation. So if we would have seen this in this form, we would have been like, okay, back in the past, I learned we could use the quadratic formula, or we could use factoring for that. And so that's the idea. So we're going to factor. So we're going to use factoring here, like mentioned up at the top. And so, but instead of having a, we have 2 cosine x squared. So to factor, how do we get a 2 cosine squared x? Well, we need a 2 cosine x here, and then a cosine x here. And then we think, how do we get 1? So what multiplies together equal 1? Well, that's pretty straightforward on this one. That's 1 times 1. So we put 1s in this spot, and that's equal to 0. And then here, we learned if two things multiply together to equal 0, then one of them has to equal 0. So we're going to write, that's not a fraction, I was just underlining. So we have Either 2 cosine x plus 1 equals 0, or cosine of x plus 1 is equal to 0. This left equation here, well, these both are similar to what we did in the first one. So this, we will subtract 1 from both sides, which gives us 2 cosine x equals negative 1, dividing both sides by 2. We get cosine of x equals negative 1/2. And so, kind of like before, we can think this negative 1/2 should be familiar to us. This is not the answer. When does cosine equal negative 1/2? Again, we could look on our chart. I'm going to have to leave us a little more space here. And if we look through and think or know, when does cosine equal negative 1/2? Well, cosine, back here, cosine is positive in the fourth quadrant and first quadrant. So in the second quadrant and third quadrant, it's negative, and cosine equals half at pi over 3. So this is going to be, we're going to have two answers. In the second quadrant, it's 2 pi over 3. And then the answer from the third quadrant is 4 pi over 3. And those are our primary solutions. Now, we're not finished. We also have to solve the second part. So we would subtract 1 from both sides. And we get cosine x equals negative 1. Again, we could use our chart, or we could remember that cosine of x equals negative 1 when x is pi. One way to remember that is, hopefully we know what cosine looks like. It looks like this. So when does it hit negative 1? That is at pi. So let's put just our final answer over here. We have, and I'm just going to put them in order. So 2 pi over 3, then pi, then 4 pi over 3. And in this case, we have 3 solutions for that equation. Moving on to the next example, we have sine of 2x equals cosine of x. We want to solve that for the interval from 0 to 2 pi. So this one's a little different. This one has a sine in it and a cosine. And in fact, it's a sine of 2x. So in this case, there's not much we can do with that. We can't factor it. And so what we're going to do is we're going to use our double angle identity. So from the identities that we learned, we know that sine of 2x is the same as 2 sine of x times cosine of x. That's one of the identities we learned. And so equals cosine of x. There's not much we can do with cosine of x to simplify that. And now we notice we have a cosine x in each of those. So we're going to subtract cosine x from both sides. That way we can end up factoring. So don't divide both sides by cosine x, because that would eliminate some answers. So we want to subtract cosine of x from both sides. And once we do that, we can factor, because now this is set equal to 0. So we see that there's a cosine x in common. So cosine x, factor that out, times 2 sine of x minus 1. And now we have two things that multiply together to equal 0. So we're going to come up here now. So either cosine of x equals 0, or 2 times sine x minus 1 equals 0. We will solve these individually. So This first one, we think, when does cosine equal 0? Well, I'm going to come back here to this highlighted portion, and I'm going to think, when did cosine equal 0? Well, equal 0 at pi over 2 and 3 pi over 2. So x equals pi over 2 or 3 pi over 2. That's how we solve that first one. Now coming to this other one, we're going to add 1 to both sides. So I'm not going to show that work, but if we add 1 to both sides, we get 2 sine of x equals 1, divide by 2. And now we're thinking, when does sine equal 1/2? So from what we've learned, or from our chart, we know sine is 1/2 at pi over 6 in the first quadrant. Sine is also positive in the second quadrant, so that's going to be 5 pi over 6. So just to put all of our answers together here, we can write x equals pi over 6, 5 pi over 6, pi over 2, and 3 pi over 2. Next one, find the primary solutions. Well, again, primary solutions was defined here, so still between 0 and 2 pi. So this is 3 cosecant x minus sine x equals 2. We can't factor anything right now. It's not set equal to 0. So if that ever happens, you might need to use an identity change to change something. So we know that cosecant x is 1 over sine of x. So 3 times 1 over sine x. You could just put 3 over sine x as well. Minus sine x equals 2. So we change the form, and now we can do some work with this. Oftentimes when we have a denominator, we like to try to eliminate that. So we're going to multiply both sides by the denominator, which is sine of x. On the left side, that gets distributed in. So when it gets multiplied by the first term there, it's just 3, because the sine x cancels. When it gets multiplied by the second term, it is sine squared equals 2 sine of x. And now we notice this is in quadratic form. So to solve quadratic form, we want to get everything on one side. We often like the squared term to be positive, so to get everything to one side, we're going to subtract 3 from both sides and add sine squared of x. So that's 0 here on the left. We're going to put this in descending order, so we have a sine squared plus 2 sine of x minus 3. Now we can factor. So how do we get a sine squared? Well, we need a sine x times a sine x. How do we get a negative 3? We'll need a 3 and a 1, one of them being negative. Since we want a positive 3 here, a positive 2, we'll want the bigger one to be positive. So this is going to be a plus 3 minus 1. And now we have two things multiplying together to equal 0. So either sine of x minus 1 equals 0, or sine of x plus 3 equals 0. On this first one, we could add 1 to both sides. We have sine of x equals 1. So we can know this. This is something we should be familiar with. With this one, kind of like up here, this was y equals cosine x. If we just graph sine x, it gives us a good idea of when sine equals 0. So here's the graph of sine. It equals 0 at 0, at pi, and at 2 pi, although we got the parentheses. When we talk about primary solutions, we don't include 2 pi. So here. You could also look at your chart. X is, I'm sorry, I just messed that up. We're looking for when sine equals 1. Sorry about that. So sine equals 1 just right here, which is at pi over 2. And that's it. Coming over to the next part, we could subtract 3 from both sides. When does sine of x equal negative 3? Well, it never equals negative 3 because sine goes up to 1 and down to negative 1 and just keeps going back and forth between those. So this part gives us no solution. That doesn't mean the whole answer is no solution, just from this part. So our answer is simply, in this case, just this number, pi over 2. All right, moving to the last two here. Solve cosine of x plus sine of x equals 1. So this is a level up here. We're leveling up. If we subtracted 1 from both sides, we still couldn't factor because there's nothing in common. There's no squared terms. Oftentimes, if we can't factor, oftentimes you want things to be the same trig ratio. But we can't do that. So, because we can't change cosine to sine because it's not a cosine squared. However, that gives us an idea. We could square both sides. So that's allowed. But just remember, when we square both sides, we have to check our solution because we could introduce extraneous solutions when we square both sides. So we're going to square both sides. This does not just square both terms. You have to multiply it by itself. Or we probably know how to multiply this mentally by now. So we're squaring both sides. Multiplying that out, we get cosine squared x plus sine x cosine x plus another sine x cosine x plus sine squared, and then is equal to 1. All right. Well, we know that sine squared plus cosine squared equals 1. I'll put that at the end here. So plus 1, that's those two things that are circled, sine squared plus cosine squared equals 1. This combines to equal 2 sine of x cosine of x. And then that's equal to 1. Well, we probably just, we can subtract 1 from both sides. That'll be nice. So that will give us 0. And we have a couple options here. We could continue to solve this, and we could think, well, this has to multiply together to equal 0. So either sine of x, 2, I mean, we got a 2 in there too, but that's not going to, 2 never equals 0. So either sine of x equals 0 or the cosine of x equals 0. So going back to my drawings, I'm going to have to make this a little smaller, but up at the top in the highlight is cosine. So when does cosine equal 0? Cosine equals 0 here and here. So for this one, that's pi over 2 and 3 pi over 2. And then when down here, the one I just boxed in, that sine, when does that equal 0? That equals 0 at x equals 0 and pi. Now, because we squared both sides, we do have to check our answers. So let's zoom in a little bit. So we're going to check all 4 answers here. Sometimes we can do this mentally. but let's go ahead and look at these individually. So we have cosine of 0 plus sine of 0, 0, not theta, equals 1. So we're coming up to our original equation here without before we squared it and seeing if it's true. I'll probably erase these later, but just as a reminder, this is cosine of theta. And this is sine of theta. This is just to help us here in a second. So we're just looking at 0 here. Cosine of 0 is 1 plus sine of 0 is 0 equals 1. So plugging in 0 worked. Now let's try plugging in pi. Cosine of pi. So again, back into the highlighted equation at the top. Cosine of pi plus sine of pi. Does that equal 1? So we're checking. Cosine of pi. Cosine of pi is right here. It's -1. Sine of pi is 0. So that is incorrect. -1 does not equal 1. So this is not one of our solutions. Coming over to our other two answers that we got, we're going to plug pi over 2 in. So cosine of pi over 2 plus sine of pi over 2. We want to know, does that equal 1? All right, coming over to our graphs, cosine of pi over 2 is right here. So that's 0. Sine of pi over 2 is right here. That's 1. So that's a check. That does work. And now 3 pi over 2 cosine of 3 pi over 2 plus sine of 3 pi over 2. Does that equal 1? Cosine of 3 pi over 2 is right here. That's 0. Sine of 3 pi over 2 is -1, which this does not work. So for that example, I'm going to have to scroll all the way down here. This didn't work. So our answer, we just have two of them, 0 and pi over 2. And the last one. This one says solve for the primary roots, so between 0 and 2 pi, to the nearest 10,000th. The nearest 10,000th, which gives me the impression that this might not give us one of our special angles like pi over 6 or pi over 3 or pi over 4. So it might, but it might not. So first things first, we have secant and we have tangent and a -1. So we can't do any factoring with those. So we want to try to change one of those. So we have all the same trig ratio. There's a couple different ways to do that, but probably the easiest way here is we have a secant squared. In fact, we have a secant squared on the left side and a -1 on the right side. So if we add 1 to both sides, so this is where you just need to get more and more familiar with these things. This would be a secant. Actually, that doesn't help us that much. Apologize. So let me back up. Does secant squared have anything to do with tangent? Does secant squared, using our identities, have anything to do with tangent? And it does. We have our Pythagorean identities, and we know our first Pythagorean identity that we learned is sine squared x plus cosine squared x equals 1. So we can't use that. But we also learned that tangent squared plus 1 is equal to secant squared. And so we can take out the secant squared and put in tangent squared x plus 1 equals 3 tangent x minus 1. And from here, this is quadratic like, so we can get everything to one side. So we'll go ahead and subtract 3 tangent x from both sides. And at the same time, we can add 1 to both sides. And so we have tangent squared x minus 3 tangent x plus 2 is equal to 0. Let's factor this if possible. Tangent x here and a tangent x here. We need to get a positive 2. So in this case, we need a minus 1 and a minus 2 to finish factoring that. And now we have things multiplying together to equal 0. So either tangent x minus 1 equals 0 or tangent x minus 2 equals 0. Now we can add 1 to both sides. And actually, this is on our radar. Like, this is one of the special angles. When does tangent x equal 1? Well, tangent x equals 1, positive 1, at pi over 4. And tangent is also positive in the third quadrant. So that would be at 5 pi over 4. And then we add 2 to both sides. We get tangent x equals 2. Now that is not on our chart. And so this is where the idea of the thousandths comes in. So we need to take the inverse tangent of both sides. Now that's technically what we've been doing on all of these, is taking the inverse trig ratio of both sides, but we knew these from our special angles, so we didn't have to write that. But now we're going to go ahead and we need to find these. So here's a calculator. We do need to make sure this is in radians, which it is, and we want the inverse tangent of 2. Now that is x equals 1.107. So that's to the nearest thousandth. That's going to be in the first quadrant. We have not done this in a while, so we have to think through. Tangent's also positive in the third quadrant. So let's say this is our 1.17 angle. We need the same angle here in the third quadrant. So to get from this angle all the way to this angle, we have to add pi. Or, since we're doing decimals, 3.14 going to thousandths, so 5. Sorry, not 5. 3.14159, so 3.142. And so our other solution, we're going to add, let's do this, let's move this down. So that's one of our answers, and then we're going to add pi to that. So adding, well, we can just come to our calculator. So plus 3.14159, and we get our other solution of 4.249. And so our answers are, we have 4 of them. They did ask us to put it in thousandths. So let's just do these on our calculator. We're going to do pi divided by 4 is 0.7 4.85. Now we're going to do 5 pi divided by 4 on our calculator. So 5 times pi divided by 4, that is 3.97. And then we have our two answers from over here. So 1.107 and 4.249. All right, there's chapter or section 5.8, solving trig equations.